Generative Agents, Interactive Simulacra of Human Behavior. This paper was written by Joon Sung Park and colleagues from Stanford University, and it was published in 2023. All the ideas and findings presented here are from their research. I'm here to break it down for you and explore the key points in a more digestible way. Imagine waking up in a cozy little town where every resident goes about their day, cooking breakfast, heading to work, chatting with neighbors. Now imagine that none of these townsfolk are real people, yet they behave so believably that you might not immediately notice the difference. They remember past events, form opinions, and even plan a party together. Sounds like a scene from a simulation game, right? In fact, it's an actual AI experiment from a 2023 research paper titled Generative Agents, Interactive Simulacra of Human Behavior. Researchers at Stanford wanted to see if AI characters could mimic the subtleties of human behavior in an open-ended environment. The result was like The Sims on steroids, a small virtual town populated by AI-driven agents with surprisingly lifelike behaviors. Background and motivation. Why would researchers build a mini-world of AI-driven Sims in the first place? Their goal was to push generative AI beyond simple text-based tasks, aiming for more interactive, human-like simulations. Think about video game NPCs, non-player characters, or virtual training simulations. Traditionally, these are hard-coded with limited scripts. The researchers envisioned generative agents, essentially AI characters powered by a language model that could wake up, converse, and interact autonomously, not by following a script, but by generating behavior on the fly. If this worked, it could transform how we build game characters, social simulators, or even educational role-play bots. The team highlighted applications from immersive game environments to rehearsal spaces for practicing social situations. In short, they wanted to create believable proxies of human behavior that could make virtual worlds feel more real. Approach, how it works in simple terms. Now let's dive into the most striking example from the study. So how do these generative agents work? Under the hood, each agent is powered by a large language model, the same kind of AI behind chatbots like ChatGPT. But the real trick is how these agents store and use information over time. The researchers designed an architecture with 3 key components. Think of them as the agent's brain processes. 1. Memory, observation. Each agent continuously records its experiences in natural language, almost like keeping a diary. For example, an agent might note, "At 9 a.m., I talked to Sam who invited me to lunch," as a memory. This complete record of the agent's experiences is stored internally. In human terms, it's akin to our ability to remember events throughout our day. 2. Reflection. Storing raw memories is good, but humans don't remember every detail. We distill memories into summaries or lessons. These agents do something similar. Over time, an agent will synthesize its accumulated memories into higher-level insights or reflections. For instance, after several days of interactions, an agent might form the reflection, "I often feel lonely in the evenings," or "Alice has been very kind to me lately." It's as if the agent is contemplating its experiences and drawing conclusions, just like we might reflect on how our week went. This step prevents the AI from getting overwhelmed by too many raw details and helps it focus on what's important. 3. Planning, using retrieved memory. When it's time to act or make a decision, the agent can retrieve relevant memories and reflections to inform its behavior. In other words, it asks itself, "What do I remember that's related to this situation?" And "What are my goals or plans?" Based on that, it decides what to do next. This is the planning process, guided by both current context and past experiences. Technically, the language model takes the agent's pertinent memories and reflections as part of its input prompt when generating the agent's next action or dialogue. The effect is that the agent's actions have continuity and apparent purpose, much like a person who remembers their commitments and plans ahead. These three pieces, memory, reflection, and planning, work together to make an AI agent that isn't just reacting in the moment, but has a sense of past and future. You can think of it like this. The AI agent has a journal of everything it's seen, memory, a set of personal insights it's learned, reflection, and a planner that uses those insights to choose its next move. Example, the Valentine's Day party. Let's talk about the most striking example from the study. The researchers populated a simple sandbox world, very much like a 2D Sims game, with 25 generative agents, each with their own persona and daily routine. Now, they give one agent a single initial idea. He wants to throw a Valentine's Day party 2 days from now. That's it. One agent gets that goal, and none of the other agents are told anything explicitly. Then, the simulation is set into motion to see what the agents will do. Over the next 2 simulated days, surprising things started happening autonomously. The agent with the party idea began inviting others to his upcoming Valentine's Day party. Those agents, in turn, remembered the invitation, and some even mentioned it to their own friends. Soon, more agents found out about the party through the grapevine. Agents started making new acquaintances because they heard about this event, striking up conversations like, "Hey, are you going to the party?" Some agents decided to ask someone out on a date to the party, just as you might invite a friend or partner to accompany you to an event. They coordinated logistics. On the day of the party, they all showed up at the right time and place together, ready to celebrate. And remember, no human scripted these interactions. All of this emerged from that one planted idea and the agent's own memory reflection planning cycle. It's a bit like dropping a single-story prompt into a group of AI characters and watching a whole narrative unfold. By the end, the researchers observed that the agents had exhibited believable individual and emergent social behaviors, essentially creating a coherent social happening, the Valentine's party, out of a single seed notion. When you hear this, you might wonder, did the agents really understand what they were doing? Of course, they're not conscious, but the illusion of believability was there. Each agent was following its programming, the LLM-based architecture, which ensured they remembered relevant info, like being invited to a party, and pursued reasonable actions, inviting others, showing up on time, consistent with that info. The resulting behavior was more complex and lifelike than anything purely hard-coded for NPCs in today's games. Analysis: why it worked and key findings. The Valentine's party scenario is a compelling demonstration of the framework's effectiveness. The researchers wanted to verify that each component of their agent architecture was actually necessary for this believable behavior. To do that, they performed what are called ablation experiments. Essentially, they tried disabling or removing one component at a time, memory, reflection, or planning, to see what happens. The findings were clear. Each component was critical. If an agent didn't have long-term memory, it wouldn't recall past details or follow-ups, making its behavior incoherent. Without the reflection step, the agent might get bogged down in trivial memories or fail to draw the bigger picture from its experiences. Without proper planning, the agent would only react reflexively without forming longer-term goals or consistency. In the paper's evaluation, they show that removing any of these, observation, planning, or reflection, made the agent's behavior significantly less believable. This validates the idea that integrating memory and reflection into LLM-driven agents is key to achieving human-like consistency in their actions. Another interesting aspect was how these agents' behaviors were perceived. The researchers informally observed that people interacting with the system found the agent's behaviors surprisingly realistic. One agent could start gossiping about the party, another might feel proud about being invited. All these nuanced interactions emerged naturally. The social dynamics, like information spreading and relationship forming, were not explicitly coded. They emerged from the interplay of agents' individual behaviors. This kind of emergent complexity is something we usually see in real societies, not AI systems, so it's quite fascinating to witness in an experiment. Wider implications and conclusion. What does this work mean for the future? It's a milestone for generative AI because it shows a way to move beyond solitary AI chatbots towards interactive, multi-agent simulations. By fusing a large language model with an agent framework, the researchers essentially gave these agents a form of imagination and experience. They can remember and invent actions in a way that mirrors human-like behavior patterns. This opens up a lot of possibilities. We could see video game worlds populated with NPCs that dynamically socialize, form memories of the player's actions, and adapt over time, making games more immersive. In educational training, we might get realistic role-playing partners. For instance, a virtual patient that a medical student can interview who will remember what's been said and change their responses accordingly. In social science research, one could even use generative agents to simulate how communities might evolve under certain conditions, as a kind of experimental sandbox. Of course, it's important to note the limitations. These agents are only as good as the underlying language model and the prompts guiding them. They don't have any true understanding or consciousness. If the LLM has gaps or biases, the agents will inherit them. And scaling this up, more agents, more complex worlds, could introduce new challenges, e.g., keeping all agents' memories consistent, or the sheer compute needed for a lot of agents running in parallel. The authors are aware that this is just a first step. But it's a promising step, showing that with the right architecture, generative models can be coaxed into generating not just text in isolation, but sustained, contextual behaviors in an interactive setting. To wrap it up, Generative Agents by Park et al. Is a breakthrough that blends NLP with simulation. It tells us that giving AI agents a memory of the past and a mechanism to introspect can make their generated behavior much more nuanced and human-like. In a very real sense, the researchers introduced architectural patterns for believable simulations of human behavior in silico. It's a fascinating development for anyone interested in the future of AI characters. So next time you're playing a life simulation game or interacting with a virtual assistant, imagine if under the hood it's running something like this: a generative agent keeping a diary of your interactions, reflecting on what you've asked before, and planning its responses to feel more personal. We're not quite there yet in consumer tech, but this research shows it might be on the horizon. It's a great example of how rapidly generative AI is evolving, blurring the line between scripted behavior and something that truly feels spontaneous. And it all started with a simple question: what if an AI could live a day in the life of a human? To which this paper's answer is an encouraging "it can." And here's how. This has been a breakdown of the paper Generative Agents, Interactive Simulacra of Human Behavior by Joon Sung Park et al. If you're interested in diving deeper into the research, you can find the full paper on ARXIV